All right, so welcome back after nearly a week off of calculus, school in general. We're going to work through a packet number 3, and then next week will be packet number 4, and then the next week is the AP test. So we're getting close. Today we're going to do topic 3, accumulating rates of change. And if we look at the formula sheet I gave you, or that's posted, the start plus accumulation is a big one for today. Yes. Zoom. Accumulating rates of change. So let's talk about what this is. F of A would be like the starting amount. F prime is a rate. And so if we integrate a rate, we get, so all of this would be the net change. So F of A is what we start with. We integrate a rate to get how much it's changed by, and then the F of B would be the ending amount. I never want to say always, but this is a pretty common free response question on the test, because they can cover a whole lot of stuff with one idea or one question. And so you look in the packet, there's 6 of them in the packet, but there's like 10 or 12 others that have been released that they're all kind of the same once you get the hang of them. So this is what we're looking at today. I guess we can just start there, and if more stuff pops up, we'll take it from there. So looking at number 1, people enter a line for an escalator at a rate. So this is a rate, so be careful. Equal to this. So this weird, and this is a calculator active question, so we won't have to worry about the weird algebra that goes with something cubed and something to the 7th, because the calculator will handle anything we need. Piecewise function. So we'll have to be careful to make sure we're in the right. So it looks a little bit weird, but it's okay. And basically, just after 300, there's no more rate, so nobody's being added. There may be people in line, but no one's being added. People enter a line. So this is people entering a line, where R is measured in people per second. As people get on the escalator, they exit the line at a constant rate of 0.7 persons per second. So I may want to write that down, and maybe we want to call it something. So R is the rate getting on. I need a letter to mean rate getting off. I don't want to use R, though. I'll use E for exiting. And exiting at 0.7 people per second. A constant. So that's good. That'll be, at least part of this problem may be easy. There are 20 people in line at time 0. So I need probably to come up with a variable that represents how many people are in line. So let's say L is people in line. So not people being added to the line, but people in the line is L. And L of 0 is 20. And I think even before I start this problem, like the number of people in line is going to roughly equal the integral of the rate, that's the people getting on, minus the people getting off, the integral of the exiters. And actually that would be a change in L. So L from 1 to 2, 1 to 2, L2 minus L1. That's a better way to say that. If you integrate a rate, you get an amount. So if I integrate the number of people getting on, or integrate that rate, that's the number of people we've added to the line. If we integrate the exiting people, that's the number of people getting off. Part A. How many people enter the line for the escalator during the time 0 to 300? So entering the line, that's R. So I want to integrate R because I want to integrate the rate from 0 to 300. So that will tell me how many are getting on the escalator, or getting in line for the escalator maybe. And since it's a calculator question, I can now just go to the calculator and let the calculator do it. And since this is a multi-part question, I probably want to put R in for Y1. That way, if I need it again, I don't have to keep typing in this ugly thing. I can just go to Y1. So it's ugly, but deal with the ugliness once rather than multiple times. Yeah, I don't think I even want to graph this really. I just want to put it in and let the calculator handle the, because that's awful. Cubed and seventh, and let's make sure I did that right. Because the calculator won't mess up the calculations. It's just if I type something in wrong. I guess I could put Y2 to be E, but that's just going to be a constant 0.7, so that's not really much. At this point, I don't really care about the graph. I just want to do the integral. Math 9, 0 to 300. Vars, that's Y1. Be careful with the dx and dt stuff. We're doing everything in x in the calculator, even though it's really dt here. So there's my answer, and I don't have to do that by hand. This is a calculator worksheet or a calculator problem, so I'm done. So that's supposed to be an easy one as long as you understand what they're asking for. Part B, or any question on that? We good so far? Integrate the rate, you get an amount. How many people? Okay, it didn't ask for units. So that means there's not really a point associated with the unit, but so you wouldn't lose points if you didn't have the unit on there. But better safe than sorry to include the unit. During the time interval 0 to 300, okay, so I got to use the crazy equation. There are always people in line for the escalator. How many people are in line at t equals 300? Well, L of 300. How many people are in line? So we have to account for the fact that people are getting off as well. There are always people in line. So L of 300 minus L of 0 would be the integral from 0 to 300 of R of t. So that's how many people have joined the line. Actually, we already know that. That's 270. Minus the number of people that were able to get off the escalator, which is going to just be 0.7 times 300. I don't really need the calculator for that one. So in line at 300 is, if I move that one over, 20, because that's how many started in line. We added 270. That was part A. And we're going to subtract 300 times 0.7. And in fact, you could safe stop that and just leave that as the answer and be done. Because that's it. In fact, I'm looking at the grading scale for this one. 2 points are associated with part B. 1 point for considers the rate out. So basically, the fact that, oh yeah, people are getting off the escalator, they're not just like piling up in the line, that's worth a point. And then this line would be worth a point. And I'm tempted to not even go any further, because why do I want to mess this up? This was a topic on my favorite Facebook page. If you keep going and you make a mistake, you will likely lose that point. So the answer is 80. If you stop here, you're fine. If you write this and then do something wrong and get 75, then you're probably going to lose the point. So safe stop when you can. Part C. By the way, I meant to keep up with this. There were 2 points for Part A, 2 points for Part B. They're always out of 9, and you're trying to get half of them. I mean, hopefully you're getting way more than half. That way, if you hit a crazy problem, you can be like, I don't know, and you've made up ground elsewhere. But hope you're aiming for 5 or 6 or 7 points per free response question. Part C. For t greater than 300. So nobody's getting on after 300 seconds. So with the people adding to the line, we're done. What is the first time t that there are no people in line for the escalator? Okay, so after 300, the number of people in line, well, I can think of it this way. This one really adds on to each other. We start at 80. Right? At 300, there's 80 people in line. And then we're losing 0.7 people per second. Although this t would need to be t after 300 or t after. So I don't know that I should put that. Maybe 0.7 times t minus 300. Might be a better way to phrase that. And we want to know when that's equal to 0. So it starts at 80, it decreases from there. So this is algebra now. But setting up the equation, I bet this is another 2 point. No, it was 1 point. Just get the answer right. So let's see, move things around. 0.7 t minus 300 equals negative 80. 80 divided by 7 is 11.4. What did I do wrong? Oh, 80 divided by 0.7. That makes more sense. 114, there we go. So my guess is some people would put 114 as their answer because it's 114 seconds after the 300 seconds. So be careful. I guess you could put that as your answer, but you don't just say 114. You'd have to say 114 after 300. But if you thought that far, then you know it's just 414.286 seconds. And that one was only worth 1 point. So let's see, that's 5 total. That means the last part's worth 4 points. So hopefully we've got 5 points, which means we're on track for a 3. But it sure be nice to get some of this last part to rack up some points here. Part D, for 0 to 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. So I need time and people in line when it's a minimum. So I need the minimum of L of t. So L of t, I think we said this already somewhere, was, we started at 20. Integral from 0 to t of r of t minus 0 to t 0.7 dt. That's L of t. How many people are on at any given time? So a minimum, if we want to find a minimum, we need to take a derivative and set it equal to 0. So L prime is, the derivative of 20 it goes away. Derivative of the integral would just be R of t. And the derivative of the integral would just be minus, we could say e of t, or we could just say minus 0.7, either one. And R of t is that weird thing up there. And we want to know, let's see, so a minimum happens, the minimum of L is when L prime changes from negative to positive. So let's go to the calculator. And we want to graph R of t minus 0.7. Well, I've already got R of t in there, so why don't I just stick minus 0.7 on at the end? I mean, I could do y1 minus y2, but it's probably easier to just go kind of manually do the y1 minus y2. Window, well, I know I need to look between 0 and 300. Y scale, who knows? I mean, X scale, who knows? Y min, Y max? There's always at least 20. And we ended at 80. Oh, wait a minute. I'm thinking the wrong thing. I'm looking for where it changes negative to positive. So I need to see where it's, I need to see the 0. So I'm going to go negative 50 to 50. And who knows if this is a good scale or not. I know the X scale is right because I got to look 0 to 300. Y scale, I don't know. This is a guess. It may not be a good one. It was not a good one. But that's what happens. Like you guess and you're like, whoops, not a good plan. Let's go back and change the Y scale to maybe negative 5 to 5. That looked pretty low down there. There we go. Okay, there's a change from negative to positive. There's a positive to negative. And then it pretty much stays down there. So we wanted negative to positive. Second calc 0. We want this 0 over here. Left bound, right bound, guess. So L prime changes negative to positive at t equals 33.013 seconds. There's our justify. There's our t answer. But I also need the number of people. Right? Wasn't that part of the line, part of the question? The nearest whole number, find the number of people in line. So I need L of 33.013. Well, I don't have to write anymore because I already told them what L is. So I'm going to use this formula that I came up with for L. 20 plus math 9. I guess if I'd really been thinking, I could have saved the 33.013, but no big deal to type it in. And since it's to the nearest person, carrying 3 decimals means I'm probably going to be okay in terms of accuracy. So that's how many people we added. And then we took off the escalator, 0.7 times 33.013. Negative 19. That doesn't sound right, does it?
0.7 still on the Y1.
What did oh, thank you. Yeah, my Y1 still had the minus 0.7 on there. which means I could have just done the y1 and not put it on the, oops. Quit. Press enter again. There we go. 3.803. That was the minimum, whoops, except it said to the nearest 4 people, so 4 people. At 33 seconds. Grading wise, it's like 1 point for L of t equals all that. No, that point was for getting the derivative. 1 point for the time, 1 point for the 4, and 1 point for the answer. This is one where I hope you guys could get the answer or get the reason maybe even without the answer. The minimum of L is where L prime changes negative to positive. Even without knowing what L prime is or using a calculator or anything, I know that one. So don't be afraid to give a reason even if you're not sure how to get there. You could get a reason point even without the answer. Although if you come up with a reason, usually that tells you how to get the answer. Alright, that was number 1. Looking at the timer, that took 20 minutes, but that was also a few minutes of intro and me going slow to explain. They're supposed to take 15 minutes, so that one probably would have pushed us a little bit.